Okay, so this is a brief video about constants. Um, there are a couple different ways that the constants in these equations can be expressed. And so I just wanted to say a few brief words on just how these equations that we are ending up with these days can be cosmetically different from each other. So the one we've been using so far, K equals 9 times 10 to the ninth Newton meters squared per Coulomb squared. That's called Coulomb's constant. And that's the one that has ended up in most of our formulas so far. There it is in the electric field formula for a point charge. Basically comes from Coulomb's law. There is, however, another way to formulate that constant through this equation, K equals 1 over 4 pi epsilon naught. So epsilon naught, this is just an alternate way to express these constants. You can work it out from this equation, not that you have to, because it is something that is on the equation sheet. Both constants here are readily available for you on the equation sheet to grab from whenever you like, but the value here is 8.85 times 10 to the negative 12, and the units here are just flipped upside down from the units of K, because of course the 4 pi doesn't affect the units at all. So besides that factor of 4 pi, these basically are inverses of each other, so that's why the units are just flips upside down. And this constant gets a different name. It's called the permissivity of free space. You'll sometimes see it called the permittivity of free space as well. So the double S in permissivity is replaced by a double T. So for instance, for a point charge, you can also choose to express it as 1 over 4 pi epsilon naught Q over R squared. Now, which one of these two is right? Well, they're both right. They're just different ways to express that same formula. I tend to prefer this statement just because it's a little more compact. This is less writing, and then this is. But there are other equations that we have coming up where they are actually more compact, being written with epsilon naught instead of with K. And so then we'll tend to favor epsilon naught a little bit more. Either way, it's just a cosmetic difference in how these equations are displayed. And I just wanted to get you caught up with that as soon as possible before we head into some of those equations where we might tend to prefer to express it with epsilon naught, just so we have less to write down.